CSMA-CD, it's a variation of CSMA. So it does have the carrier sensing mentality where you listen before transmit. Now the focus of the mechanism is CD, collision detection. So you will try to detect collision as fast as possible and as a result, abort the transmission as fast as possible. So we'll be able to reduce channel wastage this way. Now, if we use the human conversation as analogy again, this will be a super polite conversation. So in case two people detecting each other speaking at the same time, quickly back down and invite each other to speak next. Therefore, you can also see the key of the design is to detect collision. This is not that hard to do on a wire LAN. All we need to do is to measure the signal strength of the transmitted packet as well as the received packets. Now, if the received signal is significantly higher than the outgoing signals, that means there's some additional energy coming to the node. Yeah, that's an indication of collision. Now, the same mechanism might not apply for wireless LAN because the signal traveling the open air decays much faster than the signal traveling copper wire or optic fiber. So these signals arriving at the node could be too weak, such that it's overwhelmed by the local signals going out. Yeah, so CSMA-CD here is not for wireless LAN. So there's a mechanism called CSMA-CA design for wireless LAN. You might have recalled that in the overview slide earlier. So this is to showcase the benefit of CSMA-CD. So let's use the same channel having 4 nodes. At time t0, node 2 begins to send a yellow frame. And at time t1, node 4 begins to send the red frame. You see that as the yellow frame goes and goes, at this particular time point, yeah, the red frames arrived. So there's a higher amount of energy coming into the node than going out. So, collision likely. So after a while, if the situation persists, collision detected and transmission aborted. Similarly, node 4 here, after transmitting the red frame for a while, at this time point, the yellow frames arrive. There's a higher level of received signal energy than the transmitted. So after a while, after a window of observation, abort the transmission. Okay. So you see in CSMA-CD, we terminate such a case a little bit faster than CSMA. Therefore, better channel utilization in CSMA-CD. So Ethernet implements CSMA-CD as the MAC protocol. So here's how it works in detail. Step 1, NIC, the link layer of the machine, will receive datagrams from above and then encapsulate it into a data frame. So this is how we call packetting the link layer. Now the sender here then will try to listen to the channel. If it's idle, sends the frame out. If it's not, wait until it's idle, then send the frame out. So far, so good. Now, Ethernet running CSMA-CD means that it's constantly checking for collision. So, while the sender is transmitting the frame, it will check whether there's another transmission incoming. If not, yeah, this frame is received okay. Now, this is the less fortunate case. In case another transmission is detected, the sender will abort the transmission and send a jam signal out. This jam signal will go on the entire channel. All the nodes on the channel, whatever transmission they're doing, will all be aborted. And then the sender will do this. After aborting, enters the binary backoff stage. Now, in this stage, what the sender does is simply wait. How long? It waits for the time to transmit K multiply 512 bits of data. So K is determined randomly in a range 0, 1, 2 to the 2 to the power of n minus 1. And n is the number of consecutive collisions the sender experiences. So once the weight is done, the sender go back to step 2 here, meaning trying to retransmit the frame. Now in case the second trial is also a little bit unfortunate, then we enter the binary backoff again. This time, M here will increase from 1 to 2 because this is the second collision, consecutive collision. Therefore, K will be chosen in the range that's longer, 0, 1, 2, 3. Now in case M is 3, 0, 1, 2, 3, 4, 5, 6, 7. So you see the value of K is potentially exponentially higher. Therefore, the binary backoff is sometimes also called the exponential backoff. And the more consecutive collisions there are, the longer the backoff interval. Now let's check out CSMA CD's efficiency. Yeah, we unfortunately don't have the capacity to derive the formula from scratch, but hey, please accept this. Efficiency equals 1 over 1 plus phi T prop divided by T trends. So T prop represent the max propagation delay between two nodes on the LAN, and T trend is the time to transmit a big frame. Okay, so you can see that the bigger the frame can be, the higher the efficiency. Also, the shorter the propagation delay, the higher the efficiency. So overall, the efficiency can go up to close to 1. So it's overall better performance than Aloha, pure or solid. And in the meantime, CSMA CD is quite simple. Therefore, it's cheap to implement, and the mechanism is decentralized. Okay, no coordinations required.